Evaluate the indefinite integral. Here we have the integral. 4 secant tangent minus 5 over x. So here's the derivatives of the trig functions. Good to have those in your notes. Derivative sine is cosine. Cosine is negative sine. Tangent is secant squared. And secant is secant tangent. And then the ones I have in red, they come from the others. Like tangent, cotangent. You just co the answer. Instead of secant squared, it's cosecant squared, and you make it negative. Because remember, the derivative of all cofunctions is negative. See, cosine negative, cotangent negative, cosecant negative. And the same thing here. If secant is secant tangent, then cosecant's derivative is cosecant cotangent, and it's negative. All right, so have these in your notes. Here we go. So you look at 4 secant tangent. You know the 4 is just going to sit there. No big deal about him for derivatives or antiderivatives. But how do you get secant tangent? Well, secant tangent right here. So you go backwards. The antiderivative must be secant of x, right? Check it forward. Secant, we go back to secant tangent. Now, what about the other part, the 5 over x? Well, I'm going to write that as minus 5 times 1 over x. Okay, so the minus 5 is just a multiplied number sitting there. And what's the 1 over x? It's natural log of absolute value of x. Now, if you leave off the absolute value, just write regular, they'll take it. But technically, it's natural log of absolute value of x is what it is. Remember that? Remember the derivative of natural log is 1 over x? So the anti of 1 over x is natural log. Absolute values are there because you can't have negative inside of a natural log function. So there we go. There's the answer with or without the absolute values, the antiderivative. And there's no bounds. I should say there's no bounds. There's no numbers here. It's an indefinite interval. It's not defined, no bounds. So we don't need to do brackets to plug in any numbers. We just stop right there, and we do have the plus c. And there we go.